Hello everyone, welcome to this video. In this video we're going to talk about Booth's algorithm. We've already seen an algorithm for multiplication of two signed integers in our previous video. If you haven't checked out that video, I'll keep a link on top of the video and you can check it out. Now let's discuss Booth's algorithm. This is also a procedure for multiplying binary integers in sine 2's complement representation in efficient way. So we'll directly dive into our examples and then check it out. Basically, for multiplication there are three possible cases where we either multiply a positive value with a positive value, a positive value with a negative value, or a negative value with a positive value, or at last with a negative value and negative value. So we'll try to encounter example of all of these three cases and then explain you this particular flowchart which represents Booth's algorithm. First of all, start with simple example where we are trying to multiply plus 5 and plus 2. So basically we need to divide these two numbers into these two forms, BR and QR, where BR is the multiplicand and QR is the multiplier. So let's represent BR as our number 5. Its binary representation in terms of sign representation is 0 1 0 1. Represent QR as 2. In binary we write is 0 0 1 0. We also find out BR complement. So basically the ones complement of BR is 1 0 1 and 0, and also find out 2's complement of BR, which is 1 0 1 and 1. So using these values, now we're going to proceed into the algorithm. So at the start what it says is, it says us to set our accumulator to 0. Basically we're going to use 40 just as in the number of bits in our BR and QR. We'll set our Q is 0 0 1 0, and then we'll set a Qn plus 1, which is 0 in the beginning, and then we'll fix out our step counter, which is based on the number of bits in BR and QR, which is basically 4. So first of all what we're going to check is, we're going to check Qn and Qn plus 1. In this case Qn is this particular bit here and Qn plus 1 is this particular bit. So the combination of Qn and Qn plus 1 is going to determine what kind of step we're going to take next. So if you see, the combination 0 0 would take us to this particular flow here, where we're asked to do arithmetic shift AC and QR and decrease the step counter by 1. Now if you don't know arithmetic shift, I'll post a link of another video which I've made where I've clearly explained the shift operations. You can check that video out and then come back here to properly understand the process. For now I'm going to directly continue the process here. So doing arithmetic shift of AC and Q, I'll write 0 0 0 0. Basically it's a right shift, okay? So 0 0 0 1 and 0, and then we decrement the step counter by 1, which is 3. Now to understand the arithmetic shift properly here, this particular value is being copied here, this is going here, this is going here, this is going here, and this value went here, this here, this here, this value went here, and then this value went here, and then this particular value went out and then got rejected. Now one step in our algorithm is complete. Now we check if our step counter value is 0 or non-zero. If it's non-zero, then we go back to checking the status of Qn and Qn plus 1 again. Now we see that Qn and Qn plus 1 is 1 and 0. Now based on our flowchart, if we have 1 and 0 combination, then what we do is we add BR complement plus 1 to AC. So BR complement plus 1 is 1 0 1 1, AC is 0 0 0. So we are basically going to add this. We get 1 1 0 1. We copy the rest of the value 0 0 0 1 and then 0 here. Now after that the flowchart asks us to again do an arithmetic right shift of AC and QR and then decrease the step count by 1. So following the arithmetic shift again, this is going to be 1 1 0 1 1 0, 0, 0 and 1. Now the step counter is 2, and then another iteration is complete. Moving on, we again need to check if our step counter value is 0 or not. Since 2 is a non-zero value, so we go back to checking our combination of Qn and Qn plus 1. Now our combination is 0 and 1, which means we need to add Br to AC. So Br is 0, 1, 0, 1. So we're going to add the same value 0, 1, 0, 1 to AC. The result is going to be 1 plus 1, 0, carry 1. 1 plus 0 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. Now always remember that this particular carry here is rejected, and we don't consider that particular carry here. So the output of addition is 0, 0, 1, 0. We copy rest of the value as the same, 1, 0, 0, 0 and then 1. Now what we need to do is we again need to perform an arithmetic shift of AC and QR. So this is going to be 0, 0, 0, 1, 0, 1, 0, 0 and 0. Now the step counter is decreased to 1. Finally, if we check the combination again, it is 0, 0. Now since the combination is 0, 0, we again perform a arithmetic right shift here. So 0, 0, 0, 0, 1, 0, 1, 0 and then 0. Now the step counter is 0. Finally, once the step counter is 0, we come to the end of the process. Now our result is the combination of AC and Q here. So if I write the combination of AC and Q here, which is 0, 0, 0, 0, 1, 0, 1, 0, and if I convert this to decimal, I get a decimal equivalent of 10, which is a positive 10, and this is our result here. Plus 5 into plus 2, plus 2 is equal to plus 10. Now we're going to consider another example here. In the second case, we'll go for example minus 5 into plus 2, and then the result should be minus 10. We'll see if this particular approach gives us the correct result or not. So first of all, let's take our BR or B representation. This is going to be minus 5. Now representing minus 5 in binary, what we do is we perform a 2's complement of plus 5 and then represent minus 5 in that way. So first of all, we'll represent plus 5. This is going to be 0, 1, 0, 1. We'll take a 1's complement of this particular value, 1, 0, 1, 0, and then we'll take a 2's complement of this, 1, 0, 1 and 1. So BR is equal to minus 5 is equivalent to 1, 0, 1 and 1. Now if I complement this again, this is going to give me 0, 1, 0, 0, and if I add 1 to this, this is going to give me 0, 1, 0, 1. So I have my BR, I have my BR complement plus 1. I'll also assign QR or Q here, which is plus 2, which means the binary equivalent is 0, 0, 1, 0. Now start with the table again. So first of all, accumulator is going to be initialized to 0. This particular QR is going to be written here. Qn plus 1 at the beginning is always 0, and then step counter is 4. First of all, we see the combination 0, 0. We go to this particular part here. We perform an arithmetic right shift, which is 0, 0, 0, 0, 0, 0, 0, 1 and 0, and then decrease the step count by 1. After that, we again check our combination 1 and 0 here. So 1 and 0 combination asks us to add the complement of BR or the 2's complement of BR to the accumulator. So 2's complement of BR is 0, 1, 0, 1. We add this to accumulator. The result is going to be 0, 1, 0, 1. Remaining values are copied as it is, and then we're going to perform an arithmetic right shift of AC and Q, which means this is going to be 0, 0, 1, 0, 1, 0, 0, 0 and 1. Now the step counter is 2. Again, we're going to check the combination. We see that the combination is 0 and 1. Now we add BR to our accumulator. So the value of BR is 1, 0, 1 and 1. If we sum this out, we get the sum 1. 1 plus 1 is 0, carry 1 and then 1 and 1, 0, 0, 0 and 1. Now we right shift this, we get 1, 1, 1, 0, 1, 1, 0, 0, 0. Step counter is 1. We can check the combination here. So the combination is 0, 0. So what we basically need to do is perform a right shift of this operation. So 1, 1, 1, 1, 0, 1, 1, 0 and 0. Step counter is 0. Once the step counter is 0, what we do is we take our combination of A and Q, AC and Q, and this is going to be our final answer. So ACQ is 1, 1, 1, 1, 0, 1, 1, 0. Now remember that this particular answer represents some negative value. So if we want to find out what is the magnitude of this value, what we do is we take the 2's complement of this particular value. So the 1's complement of ACQ is 0, 0, 0, 0, 1, 0, 0, 1, and then the 2's complement of this particular value is, we add 1 to this, so this becomes 0, 1, 0, 1, 0, 0, 0, 0. If we find the decimal equivalent of this is going to be 10 with a sign minus, because actually the result was minus 10 in its 2's complement form. So we solved the second case too. Now we're going to see what our third case is going to be. We'll change this value from minus 5 into minus 2, and then the result should be plus 10. We have already represented our BR and BR complement plus 1. We're just going to represent QR here. QR is minus 2. So to represent this particular value, we take the value 2 first, plus 2 first, which is 0, 0, 1, 0. We take 1's complement of this, which is 1, 1, 0, 1. And then we take 2's complement of this, which is plus 1 is going to be 0, 1, 1 and 1. So this value is going to be our QR. Now again we have the accumulators. We have QR, we have Qn plus 1, always inside as 0, and then 4. We check the combination. We know that we need to do arithmetic right shift. 0, 1, 1, 1 and 0, and the step counter is going to be 3. Now if we see the combination, we see 1 and 0 here. 1 and 0 immediately means that we need to add the complement to accumulator. So 0, 1, 0, 1, we add this, we get 0, 1, 0, 1, 0, 1, 1, 1 and then 0 here. We again need to perform a right shift operation. So 0, 0, 1, 0, 1, 0, 1, 1 and 1. The step counter is going to be 2. We again see the combination of 1 and 1. Now we again need to perform a right shift operation, so which means 0, 0, 0, 1, 0, 1, 0, 1 and 1, and our step counter is 1 again. Since the combination is 1, 1, we again need to do a right shift. So 0, 0, 0, 0, 1, 0, 1, 0, and then the value 1 is here. Now the step counter is 0. Finally we reach to the end of our process. We take the combination of AC and Q. Now the combination is 0, 0, 0, 0, 1, 0, 1, 0, and then the result is 10, which is a positive 10. So this is how we perform multiplication operation using the Booth's algorithm. I hope the concept is clear to you. If you did not understand at any point, feel free to comment down and I'll try to explain you out. But try with some more examples by yourself so that the concept is more clear and then the approach is more clear to you. If you like our content, please like the video, share it among your friends and subscribe to the channel. I've noticed that a lot of you watch the video but have not subscribed to the channel. Your subscription will mean a lot to us. So please, if you like our content, do subscribe to the channel and then share it with your friends too. I'll come up with something new in the next video. Until then, happy learning. Bye bye.